Hello everyone, this is Dr. Shaik Ruksana Begam working as Assistant Professor in Electrical and Electronics Engineering Department from Institute of Aeronautical Engineering. Today I am here to give a lecture on Ohm's law and basic elements of electrical engineering. First we have to learn what are the basic components in electrical engineering. These basic components are fundamental components and concepts that form the foundation of electrical circuits. So these components will be of two types. One is of active elements and another one will be passive elements. First, coming to the active elements are nothing but which delivers energy to the sources. That means the examples of the active elements will be voltage source, current source and semiconductor devices. And coming to the passive elements will absorb energy which is delivered from the active elements. The examples of passive elements will be of resistors, inductors and capacitors. First, learning about active elements. The first one will be of current. Current is nothing but a flow of electrons in a closed path. The definition of the current will be the electric current is a flow of electric charge through a conductor. It is measured in the form of amperes. When we are designing an electric circuit, the current symbol is denoted with the arrow. If the arrow is upwards, then the current is flowing in the upward direction. If the arrow is of downwards, then the current will be flowing in the downward direction. The instrument used to measure the current is ammeter. And coming to the types of electric currents are of two types. One is direct current and another one will be alternating current. Coming to the direct current is nothing but which flows only in one direction. This type of currents are used in batteries, solar panels and electronic circuits. Then moving to the alternating current changes the direction periodically. So if we take, it is denoted, the DC current will be denoted like this and the AC current will be of alternating. Okay. Alternating current changes the direction periodically, used in household power supply which is of 50 Hz to 60 Hz. The frequency is nothing but number of cycles per second measured in Hz. In the active elements, the next one is of voltage. Voltage is nothing but the potential difference between 2 points. The definition of the voltage can be written as voltage is also known as electric potential difference, is the amount of energy per unit charge required to move a charge between 2 points in an electric circuit. This voltage is denoted with letter V and it is measured in volts. The symbol of, while designing the circuits, the symbol of voltage is taken as either positive and negative. This will be the symbol for the voltage while designing in the circuits. The instrument used to measure the voltage will be of voltmeter. So here in the voltage, again it is classified into two types. One is direct voltage and another one will be alternating voltage. As I have already mentioned in the current, it will be same for the voltage. So the direct voltage is known as a constant voltage which flows only in one direction, and this direct voltage is used in batteries, solar panels and electronic circuits. Moving to the alternating voltage will changes polarities periodically. So it is used in household power supply which is of 120 volts or 230 volts AC. It will be of 50 or 60 Hertz. Moving to the semiconductor devices. A semiconductor devices will act based on the temperature. Based on the temperature, it will act as an insulator or it will act as a conductor. Coming to the definition of a semiconductor devices is an electronic component made of materials that have electrical conductivity between that of conductor and an insulator. So basically these semiconductor devices are made up of silicon and germanium. So, silicon and germanium are the most commonly used semiconductor materials. These semiconductor devices are classified into two types. One is diodes and another one will be of transistors. Diode is nothing but a diode allows current to flow in one direction. The symbol of the diode is taken as anode and cathode. Again, coming to the transistors. Transistors are of two types. One is BJT and another one is MOSFET. BJT is nothing but bipolar junction transistor. MOSFET is nothing but metal oxide semiconductor field effect transistor. So transistors are nothing but a transistor is a semiconductor device used for switching and amplification. So these are about semiconductor devices. So, applications of semiconductor devices will be of computers and it will be used in computers and microprocessors, power electronics like AC to DC conversion, voltage regulation, communication systems like radios, cell phones, satellites, and automation and control system. And it will also be used in renewable energy sources like solar panels and energy storage systems. So these are of active elements. Then moving to the passive elements, in that first one will be of resistor. Resistor is nothing but which limits or resists the flow of current. So the definition of the resistor will be a resistor is a passive electric component that limits or resists the flow of electric current. It is denoted with a letter R. The symbol of the resistance is, so the symbol of the resistor is given here. So this will not have polarities. Depending upon the direction of the current, the resistance will be taken as positive and negative. The units of the resistance will be of ohms and it is denoted with the letter omega. The function of the resistor will be it limits the flow of current in an electrical circuit, control the voltage levels, divides voltage in circuits, converts electrical energy into heat, which is nothing but power dissipation used in filters, sensors, and voltage regulation applications. Coming to the types of resistors, they are classified into two types. One is of fixed resistors and another will be of variable resistors. Fixed resistors are also known as constant resistance, which are made up of carbon composition, metal film, and wire wound. The fixed resistance will have only a fixed value. We cannot change the value. Coming to the variable resistors, they are of adjustable resistance. They are used in potentiometers like volume knobs, brightness control. Second one will be of rheostat, which is used to control the speed of the motor and generator. Next one is inductor. An inductor is a passive electric component that stores the energy in magnetic field. Coming to the definition of the inductor, an inductor is a passive electric component that stores energy in the form of magnetic field when electric currents flow through it. It is denoted with a letter L. The units of the inductance is denoted with Henry. The symbol of the inductance is drawn in this way. As I have already mentioned for the resistance, it will not have any polarities. Depending upon the direction of the current, we can denote it as positive and negative. These are the three types of inductors. One is air core inductors, which are used. There are three types of inductors. First one is air core inductance, which is used in high frequency applications. It will be having no magnetic core. Second one will be of iron core inductors, which is having high inductance used in transformers. And third one will be ferrite core inductors used in radio frequency and power applications. These are the three types of inductors. The applications of the inductors will be used in transformers, filters, energy storage, and motor and generator applications. In transformers, it is used to transfer energy between circuits. In the filters, which is used to remove the noise from the signals. And coming to the energy storage systems, it is used in SMPS and power circuits. And then for motors and generators, it is used in converting electric energy to mechanical energy. So third one will be of capacitor. Capacitor is a passive electric component that stores energy in the form of electric field. Inductor is nothing but which stores the energy in the form of magnetic field. Coming to the capacitor, capacitor which stores the energy in the form of electrical field. It is denoted with the letter C. The units of the capacitor is farad. So I have mentioned inductance here, it will be capacitance. So the unit of the capacitance will be denoted with farad and it is denoted with the letter F. The symbol of the capacitor will be denoted like this. It will have two plates and it will not have any polarities depending upon the direction of the current. We denote it as positive and negative. Again, coming to the types of capacitors, it is classified into two types. One is fixed capacitors, another one will be of variable capacitors. Fixed capacitors are made up of ceramic, electrolytic, tantalum, and film. Coming to the ceramic capacitors will be of small size and used in high frequency applications. Electrolytic capacitors are of high capacitance used in power supply filtering, and tantalum capacitors are stable and reliable, used in sensitive circuits. And coming to the film capacitors, it is of durable and used in AC circuits. Coming to the variable capacitors, this type of capacitors are used in tuning circuits like radios. So these are the applications of capacitors. They are used in energy storage, filtering, coupling, decoupling, tuning circuits, and power factor correction. Coming to the energy storage systems, they are used in flash circuits and power backup circuits. Next, moving to the filtering, it will remove the noise from the power supply. Coupling and decoupling passes AC signals while blocking DC. And coming to the tuning circuits used in radios and oscillators, power factor correction improves the efficiency of AC power systems. Ohm's law was discovered by the German scientist named George Simon Ohm in the year 1826. He discovered Ohm's law to know the relationship between voltage, current, and resistance in the electrical circuits. Coming to the statement of the Ohm's law, Ohm's law states that at a constant temperature, the current flowing through a conductor between 2 points is directly proportional to the voltage and it will be inversely proportional to the resistance. So it states that at a constant temperature, the current I flowing to the conductor will be directly proportional to the voltage and it will be inversely proportional to the resistance. The basic formula of the Ohm's law is denoted with V is equals to IR. V is nothing but the voltage, I is current, and R will be the resistance. So we can write this formula as, if we want to find the current in the circuit, it can be written as I is equals to V by R. And if we want to find the resistance in the circuit, it can be written as voltage by current. So we'll solve one example problem in the Ohm's law so that we can understand. Before solving the problem, we are going to know the applications of Ohm's law. Ohm's law is used to find the unknown voltages, currents, and resistances in the circuits, and it is also used for designing electric circuits, example selecting resistor values. And it is also used for power calculation in electrical devices. So here is the example problem to solve Ohm's law. The first problem will be a 12 volts battery is connected to a 6 ohms resistor. Find the current flowing through the resistor. Basic formula of Ohm's law is taken as V is equals to IR. Here the value of V is given and R is given. We need to find the I. If we want to find the I, we need to take the formula as I is equals to V by R. So V is given as 12 volts and R is given as 6 volts. The value of the I will be of 2 amperes. In the same way, if we want to find the voltage in the circuit, the example problem can be taken as a circuit has a current of 5 amperes and a resistance of 4 ohms. What is the voltage across the resistor? We know the basic formula of Ohm's law, V is equals to IR. So here current is given and resistance is given. We can find the voltage easily. V is equals to IR. I is of 5 amperes and resistance is 4 ohms. The value of the V will be of 20 volts. In the same way, if we want to find the resistance, we can take the example problem as a device is connected to a power supply with a voltage of 12 volts and it draws a current of 3 amperes. What is the resistance of a device? Here voltage is given and current is given. We need to find the resistance. The basic formula is taken as V is equals to IR. From this R, we need to find R. It can be taken as R is equals to V by I. So, V is given as 12 volts and the current is taken as 3 amperes. The answer will be of 4 ohms. So that's it for the today's topic. In the next lecture, we'll be discussing of Kirchhoff laws. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.